Okay, so we're going to look at questions with pulleys. Then I'm going to actually include pulleys with ramps. So nice review for those of you who missed the lesson on ramps. Not to mention any names, Nadal. Anyway, so we have a situation here. We have a pulley with two masts on it, okay? And we're going to basically talk about the forces acting on this system and then see if we can figure it out using the concept of net force, all right? So, but here's the thing. You normally have to think about like directions, and you have to normally assign like one direction is positive and the other one is negative, right?
Did you say one direction?
I did. Wow. I did. Okay. Kids. So in this case, it's a little bit trickier. It's a little bit trickier because we also have to think about rotation. Because if you got to understand, the pulley itself isn't going to move. It's just going to rotate. It's either going to rotate clockwise or it's going to rotate counterclockwise. So what we're going to do in this case is we're going to actually say one of those rotations is positive and the other one's negative. Just like you would say up is positive and down is negative, or right is positive and left is negative. You have to also, when you think about things that are rotating, think of it this way too, right? So we're just going to say, it doesn't really matter, but we'll say clockwise is going to be positive, and we'll say counterclockwise is going to be negative, okay? So, and let's make the mass on the right 0.2 kilograms, and let's make the mass on the left 0.1 kilograms, okay? All right, now let's think about what's acting on this system. Right, they're connected, but really the only thing acting on this is gravity, right? So gravity is going to pull both objects. But here's the thing. One of those objects is going to go up. The other one's going to go down. All right. So let's think about the weight of each object, right? So let's look at the weight of this object over here. I'm going to call this object A. I'm going to call this object B. So let's think about the weight of A. The weight of A is its mass times gravity. So it's going to be 0.2 times 9.8. So what's the weight? Should be 1.96, right? 1.96. And we know that it's force, so it's newtons. Okay. Now, what is the weight of the second mass? Well, it's going to be, again, the weight is mass times G, 0.1 times 9.8, and that would be 0.98 newtons, correct? Now, here's why we can't just look at up and down in this case. Because in this case, if you look at the system, there's only, both forces look like they're just pointing down, right? So you would think there's just a net force down. But here's the thing. Because the lighter mass is attached to the heavier mass, it does experience actually another force. It experiences the weight of the heavier mass pulling it up. So now that's why we got to think about the rotation of the pulley. So let's think about then the net force, okay? Let's think about what is going to happen here. The heavier mass is going to want to cause a rotation clockwise, correct? The other mass is going to want to cause a rotation counterclockwise. Do you agree with that? So what we're going to do is, even though both forces point down, one of those two is going to be negative. Okay? What we're going to do is we're going to make this one, so because we said clockwise is positive, so we're going to make this one positive. Now, do you see why? Because that mass is going to try to turn the pulley clockwise. The other mass is going to try to turn the pulley counterclockwise. All right? So one of those two is going to be negative, the other one's going to be positive. Now we can figure out the net force. The net force is just going to be the sum of those two. So it's going to be plus 1.96 plus negative 0.98, or just 1.96 minus 0.98. That's going to give us a net force of plus 0.98. And the positive means, because we said positive is what? Clockwise? So the positive means it's going to rotate clockwise. So a question like this is really no different than questions you've done with net force. You just have to understand that even though both forces are pointing down, in reality you have to look at the rotation of the pulley, and you have to make one rotation, like going one way positive and going the other way negative, to be able to solve that question. Because if we made both forces pointing down, then you wouldn't be able to solve this question. Right? Okay. So are we okay with how we get the net force? Alright. Now, let's think about the net acceleration. Alright? Let's think about the net acceleration. So we have the net force. What would be the net acceleration in this case? So the net force is 0.98. By the way, we know F equals ma, right? So F equals ma. And we can rearrange that to A equals F over m. So our net acceleration is going to be our net force over our mass. And we have our net force. It's 0.98. But what do we use for our mass? What do you think we should use for mass? Was that the heavier one? What do you think? Is it correct? Or are they not considered one system together? Because think about what's happening. Mass A is moving down, but mass B is moving with it. Correct? Because they're attached by what? By a string. So in this case, you got to use the total mass. So this is actually going to be the total mass, which would be 0.3 kilograms. So 0.98 newtons, 0.3 kilograms. So what's that net acceleration? 3.26? So that's what you should have got, around 3.26. Don't worry if you didn't, but the math of it all says it should be about 3.26. Yeah, you were. You guys got 4.2, 4.1. Blame your phone. So that's the net acceleration. That's not the whole question, because the other part of the question is determining the tension in the string. Okay? Because there is tension in the string, and tension's a force. So what we're going to do is we're going to figure out, how do you get the tension now? So let's think about one of the blocks, or one of the masses, okay? So I'm going to calculate the tension. I'm going to slide it in over here. I'm going to look at the heavier mass, which was mass A. And I'm just going to look at basically the two forces acting on mass A, okay? So I have mass A, and I know that mass A is experiencing weight due to gravity, right, which is a force. And I already know that force is 1.96 newtons down, correct? But it's also experiencing tension, because the lighter mass is trying to pull it up, right? So there is a tension that's pointing up, but we don't know what that tension is. We have no idea what that tension is, okay? But we're going to solve it. Because we know the block is accelerating with a net acceleration of 3.26 meters per second squared, right? And if you remember, F net is mass times net acceleration, but Fnet is also the sum of the forces. So we can also think of it as basically, well, if we make down negative, we can make up positive. So we can say tension minus the weight is also your net force. So now let's look at what you can do here. You can say, well, tension is really then F net plus the weight, correct? Right? We have two equations for F net. F net equals mass times net acceleration. And we also have F net equals tension minus the weight. Okay, so we're solving for the tension. By the way, intuitively speaking, tension has to be less than what value? 1.96, right? The tension has to be less than 1.96. Because if the tension was greater than 1.96, this mass would be moving which way? Up. So always try to kind of visualize or have an idea of what your answer should be. What's our net force? It was 0.98, right? Now, 0.98 plus our weight. What's the weight? What was it? 1.96? But let's be careful here. Hold on, let's be careful here, right? We got a problem here, don't we? Our net force was positive 0.98, correct? If we add those two numbers up, we're going to get a number that's bigger than 1.96. So there's a problem here. Either we made a mistake, or we're not interpreting the sign correctly. Initially, we did not talk about up and down. We said positive is clockwise, and negative is counterclockwise. So this positive 0.98, does that mean down or does that mean clockwise? It means clockwise. But which way is the mass moving? Which way is the heavier mass moving? It's moving which way? It's moving down, right? Okay, so then this should be negative. So then our tension would be 0.98. Let me pause it for now, okay? And I'll take questions. Okay, so let's look at this question now. We're gonna similar, but not quite the same. Still pulley, two masses, but one of the masses resting on a platform, no angle, and there's a coefficient of friction. Okay, so we're gonna do the same thing as we did before. We're gonna say, well, okay, we'll make this way positive, so clockwise is positive, and then we'll do counterclockwise. Going the other way will be negative. Okay, so let's think about the forces then acting on this system, right? We have two blocks. Maybe I should use a different color. A and B. And by the way, in these questions, I guess you're going to assume there's no friction in your pulley. Okay, because we didn't consider friction in the pulley in the previous example. So there's friction between the block and the platform or the ground, but there's no friction in the actual pulley system itself, okay? All right, so we have a force acting down, correct, from mass A, right? And that's going to cause clockwise rotation in the system. And that force is its weight. So it's mass times G, 1 times 9.8. So that's 9.8 newtons. Right? There's also force from friction. And that's going to want to cause counterclockwise rotation. Now, friction can't actually do that, but if we can think of it that way, then we can figure out what its sign is, okay? So, what is the force of friction going the other way? Well, it's mu Fn. That would be 0.5 times the normal force. Now, in this case, the normal force is what? So, review. If it's no angle, that means the normal force, and you're not pushing down on it and you're not pulling up on it. If you just have an object resting on a surface with no angle and no other forces, the normal force is the same as the weight. Okay? And the weight, because this block has the same mass as the other block, the weight is also 9.8 newtons. Right? Because they're both 1 kilogram masses. So the force of friction in this case is 4.9 newtons. Okay? So now you have your two forces. You have one force that's going to cause clockwise rotation, and you have another force that's going to resist that. So when you do your net force is going to be 9.8 minus 4.9, which is 4.9 newtons. Positive, which means the pulley is going to rotate clockwise. If we want to know then the acceleration of the system, the net acceleration, that's the net force over the total mass, 4.9 over 2. You got to add because they're stuck together through the string, right? And that's going to give you a net acceleration of about 2.45 meters per second squared. Now, what direction? Again, if you think about from the perspective of the pulley, that will be that'll be clockwise. If you think about it from the perspective of block B, that would be which direction? The block. Just this block. Which way would it move? Right or left? It would move this way. If you think about it from the perspective of mass A, it would be down. Right? So it's about different perspectives, I guess. If you think about it from the perspective of the pulley, it would be clockwise rotation. Right? Okay, so that's the net acceleration. Okay, so now let's figure out the tension. We're going to do the exact same thing we did before. So let's think about, again, let's think about block A. And by the way, in the previous example, you could have done the tension for looking at the other mass. You could pick any of the two masses in your system and figure out the tension, because it should be the same. So going back to this question, the tension we worked out as what? 0.98. That would be the same on both sides. So we could have solved for tension using the other mass. It would have worked also. Yeah, would have worked also. So in this case, we're going to solve for the tension. We can look at it from the perspective of, I guess, block B. Maybe that might even be easier. So let's look at block B, okay? We know block B is experiencing a net force of, a net acceleration of 2.45 meters per second squared to the right, correct? So we can work out for block B the net force. So that would be its mass times the net acceleration, right? That would be what? 1 times, what's the net acceleration? 2.45, and we'll just say to the right. So that gives us a net force of 2.45 newtons. Right? Is a net force. What are the forces acting on block B though? We got tension. Which way is tension pulling? Which way is this string going to pull? Right or left? Pull right. And then we have friction in the opposite direction. So if you think about the net force on B, the net force on B is going to be, let's squeeze it in over here. It's going to be the tension minus the friction. Agree with that? We have tension pulling one way, and we have friction pulling the other way. The net force is going to be the sum of those two. So how do you solve for tension then? Tension is going to be the net force plus friction. So let's finish this off. So what's our tension? Net force was 2.45 newtons. Our friction, we worked out, was 4.9. So then our tension ends up being 7.35 newtons. And let's see if that makes sense. Okay? 7.35 newtons. So if our force of friction is 4.9, this is 4.9, then the tension has to be what? Greater. So that makes sense. 7.35 newtons, and I guess I should write to the right. Okay? And now we'll do one more example. That include a ramp for our South American friend who missed class yesterday. Okay, I'll pause it here. Okay, ladies, last question, alright? So you have a ramp now with a pulley. So now we're going to have also the force down the ramp. So let's think about, again, we have clockwise rotation, and then we have counterclockwise, okay? So clockwise will be positive, counterclockwise will be negative. So what will be the forces that will cause this thing to rotate? So we're going to look at the force down the ramp, because the thing about friction, we don't know which way it's going to act unless we figure out the difference in their weights first. Okay, so let me explain that. So we know that this box is going to experience a force down the ramp, right? And that force down the ramp, dr, is a function of its weight times the sine of the angle, in this case sine 30, which we know is 0.5. The weight, so the block has a mass of 3 kilograms. G is 9.8. Sine of 30 is 0.5. So the weight is, what is that? 14.7? So it's 14.7 newtons, right? Wait, okay?
I'm still confused about which mass, which block has which mass.
Oh yeah, okay. I know. Don't blame you. So this is 3. I think I may have said I was going to do the other opposite, right? So this is 3, that's 1. Yeah. There's a reason I don't teach English. Okay. Okay, so that force on the ramp is going to cause clockwise rotation, right? So we're going to make this force positive. So let's think now about the mass that's being suspended. the 1 kilogram mass. So let's think about its weight. Its weight is mg, so that's 1 times 9.8, which is 0. So that's 9.8. Sorry, so it's 9.8 newtons. Okay, so it's 9.8 newtons. All right, now, which way will that turn the pulley? Right. So we're gonna give that a negative sign, right? And then we'll work in the friction, because the friction doesn't play into account until we know which way the thing's gonna move. So let's work out the net force. The net force is gonna be the sum of those two forces. So it's gonna be 14.7 minus 9.8. What is that? 4.9. And it's positive, which means pulley rotates clockwise, which means the object will slide down the ramp, which means this mass will move up. Correct? But here's the thing, though. That's the net force, right? There's also friction. Once we know the net force, we're going to figure out then what that friction is, because the friction is going to slow it down. So let's work out the friction. So if you remember, normal force in a ramp is a function of what? It's weight times cosine theta. So mu is 0.3. Its weight is 3 times 9.8 times cosine of 30. So what's my friction? So what's my friction? 7? Wow. Okay. 7.64? Is it that high? All right. So then, if that's the case, what do you think is going to happen? That's a good question. This is my fault because the numbers I picked are not great. But we can still answer this question. In fact, what's going to happen is something interesting. It's not going to move. It won't move. Why not? Is it? Is that right? 7.64? Okay. So then, if that's the case, then think about really what's going on here. There is a net force acting down, but friction is greater than that net force acting down. What's going to happen then is this object won't move. It will not move. Friction cannot cause something to move backwards. Friction cannot make this thing move up the ramp. What friction only does is stops or hinders the progression of motion, right? So right now, if we took away friction, which way would this system move? Down the ramp. With friction, guess what happens? It doesn't move. So this value, because this value is greater than this value, the system doesn't move. Why don't we end there, and when we come back, we'll talk more about questions like this, okay?